Welcome to Mana Labs. In today's math session, we will cover differentiation. To outline the derivatives of some functions, let's note the following results. D by dx of x power n is equal to n into x power n minus 1, where n is an integer. So we'll extend this to some of the other functions which you can remember. D by dx of a constant is 0. D by dx of x is equal to 1. D by dx of 1 by x is equal to minus 1 by x squared. D by dx of root x is equal to 1 by 2 root x. So let's take an example. Say d by dx of x squared is equal to, here you will recognize n is equal to 2. So n, which is 2, into x power n minus 1, which is 2 minus 1, that is 1. So differential of x squared is 2x. On the other hand, if you had a negative integer, say x power negative 2. So n is negative 2 here. N into x power n minus 1. Negative 2 minus 1. So minus 2 into x power minus 3. And we can rewrite this as minus 2 over x cubed. Next, we will note the derivatives for trigonometric functions. D by dx of sin x is equal to cos x. Differential of cos x is equal to minus sin x. Differential of tan x is equal to secant squared x. Differential of cot x is equal to minus cosecant squared x. D by dx of secant x is equal to secant x tan x. Differential of cosecant x is equal to minus cosecant x into cot x. Next, exponential and logarithmic functions. So d by dx of e power x is equal to e power x. D by dx of a power x is equal to a power x into log a. D by dx of log x is equal to 1 by x. Now we'll look at rules of differentiation. First, addition rule. D by dx of u plus v. So this is the form, and u and v are both functions of x. So you can write this as du by dx plus dv by dx. The same can be extended to subtraction or difference, which is d by dx of u minus v, which is now equal to du by dx minus dv by dx. Next, say you had a constant along with the function. So let me write that form as d by dx of c into f of x, where c is a constant. So we can take the c outside the derivative and differentiate the function. Next, product rule. So we have d by dx of u into v, which is u into dv by dx plus v into du by dx. So another way you can remember this is first function into differential of the second function plus second function into differential of the first function. Next, we'll note the quotient rule, which is of the form d by dx of u by v, which is v into du by dx minus u into dv by dx divided by v squared. So another way you can remember this is denominator into differential of the numerator minus numerator into differential of the denominator divided by denominator whole squared. So let me clear this. We'll go to some examples here. Question is to differentiate each of the following with respect to x. First question, y is equal to sine x cubed. So we notice there are two functions. So differential of sin x is cos x. Differential of x cubed is 3x squared. The differential of x power n is n into x power n minus 1. Therefore, dy by dx is equal to differential of sine is cos, so cos x cubed, into differential of x cubed, which is 3x squared. So let me write my final answer in this form: 3x squared cos x cubed. Next question. Y is equal to cos cubed x. So let me rewrite this as cos x whole cubed. So now let me note d by dx of x cubed is equal to 3x squared. D by dx of cos x is equal to minus sin x. So now dy by dx is equal to differential of x cubed is 3x squared. In this case, 3 cos x whole squared into differential of cos x, which is minus sin x. So let me rewrite my answer here. Minus 3 sin x into cos squared x. Next question. Y is equal to tan root x. D by dx of tan x is equal to secant squared x. D by dx of root x is 1 by 2 root x. So therefore, let's start differentiating here. Dy by dx is equal to differential of tan is secant squared. So I write this as secant squared root x into differential of root x, which is 1 by 2 root x. So I can write my final answer in this form: secant squared root x divided by 2 root x. Clear this? Next question. Y is equal to ax plus b whole power m. So we have a power function and we have an algebraic function. So dy by dx is equal to m into ax plus b whole power m minus 1. So remember, differential of x power n is n into x power n minus 1 into coefficient of x, which is a. Okay, so my final answer will be of the form am ax plus b whole power m minus 1. So in differentiation, make a note, you will always multiply by the coefficient of x. So in this case, you had ax plus b. So this, if you were to differentiate, a is a constant, d by dx of x plus d by dx of b, which is a constant. So a into differential of x is 1 plus differential of b is 0. So I get the answer as a. Next question. Y is equal to 2x plus 3 whole power 5. So dy by dx is equal to 5 into 2x plus 3 whole power 4 into coefficient of x, which is 10. So I can write my final answer as 10 times 2x plus 3 whole power 4. Next question. Y is equal to square root of ax squared plus bx plus c. So dy by dx is equal to differential of root x is 1 by 2 root x. So in this case, 1 by 2 root of ax squared plus bx plus c into a is a constant, differential of x squared is 2x, plus b is a constant, differential of x is 1, plus differential of c is 0. So I can rewrite this as numerator becomes 2ax plus b divided by denominator remains the same, twice a root of ax squared plus bx plus c. Okay, so now let me clear this. Next question is y is equal to cos squared x squared. So let me rewrite this as cos x squared whole squared. So therefore, dy by dx is equal to differential of x squared is 2x. So in this case, 2 cos x squared. Differential of cos is minus sine, so minus sine x squared into differential of x squared, which is 2x. So my final answer will be minus 4x sine x squared into cos x squared. Next question. y is equal to sine cos x squared. So dy by dx is equal to differential of sine is cos. So cos of cos x squared. Differential of cos is minus sine x squared into differential of x squared is 2x. My final answer can be written in this form: minus 2x sine x squared cos of cos x squared. Next question. Y is equal to sine of square root of sine x plus cos x. So dy by dx is equal to differential of sine is cos. So cos square root of sine x plus cos x into differential of root x is 1 by 2 root x. 1 by 2 root of sine x plus cos x into differential of sine x is cos x. Differential of cos x is minus sine x. That's the answer. Okay. Next question. Y is equal to sine of square root of sine root x. So let's do this step by step. Dy by dx, differential of sine is cos. So cos root of sine root x into differential of root x is 1 by 2 root x. In this case, 1 by 2 root sine root x into differential of sine is cos. So cos root x into differential of root x, which is 1 by 2 root x. So therefore, we can write the answer here: cos root of sine root x into cos root x divided by 4 root x into sine root x. That's my final answer. Let me clear this. Next question. Y is equal to 1 by square root of a squared minus x squared. So let me rewrite this as a squared minus x squared whole power negative half, because we know root x is nothing but x power half. So if I had 1 by root x, I can write it as x power negative half. So now let me differentiate. Dy by dx is equal to n, which is minus half, x power n minus 1. A squared minus x squared whole power minus half minus 1 into differential of a squared is 0. Differential of minus x squared is minus 2x. So here 2 gets cancelled. Minus minus results in positive x, and this is a squared minus x squared whole power minus 3 by 2. So I can rewrite my final answer as x by a squared minus x squared whole power 3 by 2. Bring it to the denominator. The exponent becomes positive. So clear this. Next question. Y is equal to square root of 1 minus tan x divided by 1 plus tan x. So now let me begin with making a substitution. Let 1 minus tan x divided by 1 plus tan x be equal to t. So y is equal to root t, which is nothing but t power half, right? So now if y is a function of t, so if I were to differentiate y with respect to t, dy by dt is equal to 1 by 2 root t. Okay. Then here t is a function of x. So if I were to find dt by dx, I can apply the quotient rule. Okay. So let's see the application of the quotient rule in order to find dt by dx. So denominator, which is 1 plus tan x, into differential of the numerator, which is minus secant squared x, minus numerator into differential of the denominator, the whole divided by denominator whole square, which is 1 plus tan x whole square. So what is this equal to? Dt by dx. So let's simplify this, and we get minus secant squared is common. So we're left with 1 plus tan x plus 1 minus tan x, and the whole divided by 1 plus tan x whole square. So plus tan x minus tan x gets cancelled. 1 plus 1 is 2. Minus 2 secant squared x in the numerator, and 1 plus tan x whole squared in the denominator. So let me continue to simplify this. I want you to make a note of this. dy by dt, and this is dt by dx. Let me clear this. Now, our objective is to find dy by dx. Okay, dy by dx, which is equal to dy by dt into dt by dx. So now we know dy by dt is 1 by 2 root t. 1 by 2 root, what is t? Based on the substitution, 1 minus tan x divided by 1 plus tan x into dy dt by dx. Okay, so dt by dx, we got the value to be minus secant squared x divided by 1 plus tan x whole squared. Okay, so let me rewrite this as minus secant squared x into root of 1 plus tan x divided by 1 minus tan x whole part half into 1 plus tan x whole square. So that gives me minus secant squared x divided by 1 minus tan x whole power half, and this in the denominator becomes 1 by 1 plus tan x whole power 2 minus half, because in the numerator I have 1 plus tan x whole power half. So I'm applying the laws of exponents here. So that gives me minus secant squared x divided by 1 minus tan x whole power half into 1 plus tan x whole power 2 minus half is 3 by 2. That's my final answer. Okay, so now let me clear this. So next we look at derivatives of exponential and logarithmic functions. First question, y is equal to e power x squared. So dy by dx is equal to differential of e power x is e power x, so in this case e power x squared, into differential of x squared, which is 2x. So I'll rewrite the answer, 2x e power x squared. Next, y is equal to e power minus 3x. So dy by dx is equal to differential of e power x is e power x, so e power minus 3x into coefficient of x, which is minus 3. So minus 3 e power minus 3x. Next, y is equal to e power cos x. So dy by dx is equal to differential of e power x is e power x, so e power cos x into differential of cos x, which is minus sin x. So I'm going to rewrite this minus sin x into e power cos x. Next question, y is equal to sine of log x. So dy by dx is equal to differential of sine is cos, the cos of log x, into differential of log x is 1 by x. That's my answer, cos of log x divided by x. Next question, y is equal to log of log x. So dy by dx is equal to differential of log is 1 by x, so 1 by log x into differential of log x, which is 1 by x. So I'll write my final answer in this form, 1 by x log x. Next question, y is equal to e power root cot x. So dy by dx is equal to differential of e power x is e power x, so e power root cot x into differential of root x is 1 by 2 root x. In this case, 1 by 2 root cot x into differential of cot x, which is minus cosecant squared x. So I'll write my final answer, minus cosecant squared x e power root of cot x divided by 2 root of cot x. So let me clear this. Next question, y is equal to log of tan x by 2. So dy by dx is equal to, we recognize there are three functions here, logarithmic, trigonometric and algebraic. So we need to differentiate 3 times. Differential of log is 1 by x, in this case 1 by tan x by 2. Into differential of tan is secant squared, so secant squared x by 2 into coefficient of x, which is 1 by 2. So I can write my answer here as secant squared x by 2 divided by tan x by 2, and you have 1/2 here. So I can also simplify. We know secant x is 1 over cos x, and we also know tan x is sin x by cos x. So I'm going to simplify this. 1/2 into secant squared x by 2 is 1 by cos squared x by 2 divided by sin x by 2 divided by cos x by 2. So 1 cos x by 2 gets cancelled. So this results in 1/2, and then we have sin x by 2 into cos x by 2. Okay. Now this is nothing but 1 by half angle formula. We know sin 2 theta is 2 sin theta cos theta. So I can write this as 1 by sin x. So the answer is cosecant x. Okay. So now let me clear this. Next question is y is equal to 1 by log of cos x. So I can rewrite this as log of cos x whole power -1. Okay. So dy by dx is equal to -1 log of cos x whole power -1, which is -2. Differential of log is 1 by x. So in this case 1 by cos x into differential of cos x is minus sin x. So therefore minus minus becomes plus. Sin x by cos x is tan x, and I'll bring the negative power to the denominator. So that makes it log of cos x whole squared in the denominator. So that's my final answer. Clear this? Y is equal to square root of e power root x. So dy by dx is equal to differential of root x is 1 by 2 root x. 1 by 2 root e power root x. Into differential of e power root x is e power root x. Into differential of root x is 1 by 2 root x. So I can write the final answer in this form. E power root x divided by 4 root x into square root of e power root x. Now suppose you had x over root x. This is nothing but root x. So therefore I can rewrite my answer as square root of e power root x divided by 4 root x. Okay, clear this? Next question is y is equal to log of x cubed. So you have 4 functions here. So let's differentiate 4 times. Dy by dx is equal to differential of log is 1 over x. So in this case 1 over log of log x cubed into again differential of log is 1 over x. So that becomes 1 over log x cubed into differential of log x is 1 over x, so it becomes 1 over x cubed into differential of x cubed, which is 3x squared. So therefore, I should be able to write my final answer in this form, which is 3x squared divided by x cubed into 1 by log of log x cubed into 1 by, now look at this, log of x cubed. Okay, we'll use the power property of logarithms. I can rewrite this as 3 log x because you know log of x power k is equal to k log x. So I'm applying this property and I'll write this as 3 log x. So here 3 cancels and I have x left here. So my final answer can be written in this form: 1 by x log x into log of log x cubed. Clear this? Next one, y is equal to e power ax cos bx plus c. Okay, so we'll apply the product rule. Dy by dx is equal to first function into differential of cos is minus sine bx plus c into coefficient of x, which is b, plus second function into differential of first function e power ax into coefficient of x, which is e. Let me rewrite the answer. as minus b e power ax sine bx plus c plus a e power ax cos bx plus c. So I can take e power ax common. Let me write the positive term first. That gives me a cos bx plus c minus b sine bx plus c. Okay, let me clear this. Next question. Y is equal to log square root of 1 plus sine squared x divided by 1 minus sine x. Now, root x can be expressed as x power half. Now, suppose I had log of root x. I can write this as log of x power half. Applying the power property again, that is log of x power k is k log x. I can write this as half log x. So, this is one property. Another property that you can apply here is log of m by n, which is equal to log m minus log n. So therefore, I'll rewrite this as half log one plus sine squared x minus log of 1 minus sine x. So I've applied both these properties and now I can simplify y in this manner. So now that this is y, let me start differentiating. dy by dx is equal to half as a constant. So first function, let us differentiate. Differential of log is 1 by x. In this case, 1 by 1 plus sine squared x into differential of 1 is 0. Differential of sine squared x is 2 sine x into differential of sine x is cos x minus, this is again differential of log is 1 by x. 1 by 1 minus sine x into differential of 1 is 0. Differential of minus sine x is minus cos x. So I'll rewrite this half. 2 sin x cos x is sin 2x divided by 1 plus sine squared x. Minus minus makes this plus. This is cos x divided by 1 minus sin x. So that's the form of my final answer. Let's clear this. Y is equal to log sine e power x plus 5x plus 8. So again we'll apply the as a composite function here. Okay, so dy by dx is equal to differential of log is 1 by x. So in this case 1 by sine e power x plus 5x plus 8. Differential of sine is cos. So cos of e power x plus 5x plus 8 into differential of the function, this function, which is e power x is e power x plus differential of 5x is 5. Differential of 8, which is a constant, is 0. So I'll write my final answer in this form. Cos by sine is cot. Okay, so e power x plus 5 into cot e power x plus 5x plus 8. Okay, let's clear this. Moving on, next section is derivatives of inverse trigonometric functions. Of inverse trigonometric functions. Let's list them before we go to the questions. So d by dx of sine inverse x is equal to 1 by square root of 1 minus x squared. D by dx of cos inverse x is equal to minus 1 by square root of 1 minus x squared. Next, d by dx of tan inverse x is equal to 1 by 1 plus x squared. D by dx of cot inverse x is equal to minus 1 by 1 plus x squared. D by dx of secant inverse x is equal to 1 by x root of x squared minus 1. So d by dx of cosecant inverse x is equal to minus 1 by x root of x squared minus 1. So now let's move on to questions based on these derivatives. First question, y is equal to sine inverse of 2x. So now if I were to differentiate, I'll get dy by dx. Differential of sine inverse of x is 1 by square root of 1 minus x squared. In this case, 1 minus 2x whole squared into coefficient of x, which is 2. So my final answer is going to be 2 divided by square root of 1 minus 4x squared. Next question, y is equal to tan inverse of root x. So dy by dx is equal to differential of tan inverse of x is 1 by 1 plus x squared. In this case, 1 by 1 plus root x whole squared into differential of root x, which is 1 by 2 root x. So write my final answer, 1 by 2 root x into 1 plus x. Okay, let me clear this. Next question is y is equal to cos inverse of cot x. So dy by dx, differential of cos inverse is minus 1 by square root of 1 minus x squared. In this case, 1 minus cot squared x into differential of cot x, which is minus cosecant squared x. So minus minus becomes plus. I can rewrite the answer as cosecant squared x divided by 1 square root of 1 minus cot squared x. Let me clear this. The next few questions is where we're going to use substitution. So say y is equal to secant of tan inverse x. So I'm going to put tan inverse x is equal to t. So differentiating both sides, I get dt by dx is equal to 1 by 1 plus x squared. But here, based on substitution, y is equal to secant t. So y is a function of t. Let me find dy by dt. dy by dt is secant t into tan t. So now I need to find dy by dx. So dy by dx is nothing but dy by dt into dt by dx. So that gives me secant t into tan t into 1 by 1 plus x squared. So secant t is nothing but square root of 1 plus tan squared t. So I can rewrite this as square root of 1 plus tan squared t into tan t divided by 1 plus x squared. So that is square root of 1 plus tan squared t. So based on this substitution, if tan inverse x is equal to t, then tan t is equal to x. So I can write this as x squared, and what is tan t? X divided by 1 plus x squared. So we have root x divided by x. So in the denominator, I'll have the final answer in this form, x divided by square root of 1 plus x squared. This. Next question is y is equal to e power tan inverse of root x. So now dy by dx is equal to differential of e power x is e power tan inverse of root x into differential of tan inverse of root x is 1 by 1 plus root x whole squared into differential of root x is 1 by 2 root x. So my final answer can be written in this form, e power tan inverse root x divided by 2 root x into 1 plus x. Okay, clear this. Next, we'll look at differentiation using trigonometric identities. So let's note some of the important trigonometric identities here. Um, 1 minus cos x is equal to 2 sine squared x by 2. 1 plus cos x is equal to 2 cos squared x by 2. Then we also have, say, sine squared x plus cos squared x is equal to 1. So sine 2x is equal to 2 sin x cos x. Cos 2x is equal to cos squared x minus sin squared x can also be written as 2 cos squared x minus 1 also equal to 1 minus 2 sin squared x. Now this what we have noted is half angle. The same thing can be written as 1 minus cos 2x is equal to 2 sin squared x, or 1 plus cos 2x is equal to 2 cos squared x. Okay, let me clear this. And next, also we'll note this in half angle form. Sin x is equal to 2 tan x by 2 divided by 1 plus tan squared x by 2. Also, cos x is equal to 1 minus tan squared x by 2 divided by 1 plus tan squared x by 2. And also we know from the identity tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y by 1 plus xy. Also say it is tan inverse of x plus tan inverse of y. Then we can write this as tan inverse of x plus y by 1 minus xy. Okay, so let me clear this. And next, I'm going to outline some of the useful substitutions. Suppose we are given sine inverse of f of x, cos inverse of f of x, and tan inverse of f of x. This is important. It will help you even in integration in one of the subsequent chapters. So some useful substitutions. So say you had, when will you apply this? Say you have sine inverse of f of x, or you had cos inverse of f of x, or basically any of the trigonometric functions, tan inverse of f of x. Okay, then say you had f of x is equal to square root of a squared minus x squared, then you'll use a substitution x is equal to a sine theta or x is equal to a cos theta. Next, if you had f of x in the form square root of a squared plus x squared, you will substitute x is equal to a tan theta or x is equal to a cot theta. Next, if you were to have f of x in this form, square root of x squared minus a squared, then you will plug in x is equal to a secant theta or x is equal to a cosecant theta. Now, one other format, which is say f of x is equal to square root of a minus x. Then I'm simply going to put x is equal to a cos 2 theta. Okay, this is important for you to remember, and it will help you in questions based on substitution. So with that, next we will move on to questions where we're going to apply some of the um, trigonometric identities that we just noted. First question, y is equal to tan inverse of 1 minus cos x by sin x. So let me simplify what is inside the brackets here. 1 minus cos x divided by sin x. So 1 minus cos x we know from the identity 2 sin squared x by 2. Sin x half angle formula is 2 sin x by 2 cos x by 2. So let me simplify. 2 gets cancelled. 1 sin term gets cancelled. I am left with sin x by 2 divided by cos x by 2, which is nothing but tan x by 2, because sin over cos is tan. So y is now equal to tan inverse of tan x by 2. So tan inverse of tan x is x. So in this case, y is equal to x by 2. So what is dy by dx? Simply the coefficient of x, which is 1/2. Okay, clear this. Next question is tan inverse of cos x minus sin x divided by cos x plus sin x. Okay, so this is an important form for you to remember. cos x minus sin x divided by cos x plus sin x. So when you see this form, you can choose to divide both the numerator and denominator by cos x. So therefore, cos x divided by cos x is 1 minus sin x by cos x is tan x divided by denominator is going to be 1 plus tan x. Now I'm going to introduce a 1 here. For this 1 and this 1, which is the multiplicative identity, I'm going to substitute tan pi by 4 because we know tan pi by 4 is equal to 1. So tan pi by 4 minus tan x divided by 1 plus tan pi by 4 into tan x. Now this is of the form tan a minus tan b over 1 plus tan a tan b, which is equal to tan of a minus b. So tan of pi by 4 minus x. So let's come back and use it here. This is y, which is equal to tan inverse of tan pi by 4 minus x. So y can now be rewritten as tan inverse of tan x is x. In this case, it is pi by 4 minus x. So dy by dx is equal to differential of pi by 4, which is a constant, is 0. And differential of minus x is minus 1. So that's the answer. Let me clear this. Next question. Y is equal to tan inverse square root of 1 plus cos x divided by 1 minus cos x. So let me simplify the terms here. 1 plus cos x divided by 1 minus cos x. Numerator is 2 cos squared x by 2. Denominator 2 sin squared x by 2. 2 gets cancelled. Cos by sin is cot. So I can write this as cot squared x by 2. What is square root of this? Will give me cot x by 2. So I'm going to rewrite this tan inverse of cot x by 2. But then for me to be able to apply the property from inverse trigonometry, I need to rewrite this in terms of tan. So tan inverse of tan pi by 2 minus x by 2, because we know tan of 90 minus theta is cot theta. So now tan inverse of tan x is x. So in our case, y becomes pi by 2 minus x by 2. Now let's differentiate. dy by dx is differential of pi by 2 is constant 0 minus coefficient of x is simply half. So my answer is negative half. Okay, now let me clear this. Next question is y is equal to square root cos inverse. Just do this here. Cos inverse of square root of 1 plus cos x divided by 2. So what is 1 plus cos x by 2? This is in half angle. 2 cos squared x by 2 divided by 2. 2 gets cancelled. Square root of cos squared x by 2 is simply equal to cos x by 2. Let me rewrite here. Y is therefore equal to cos inverse of cos x by 2, which gives us x is equal to x by 2. Therefore, differentiating both sides, I get dy by dx, which is coefficient of x, which is equal to 1/2. Okay. Next, let me clear this. And let's take this question. Y is equal to cos inverse of 1 minus x squared divided by 1 plus x squared. So here, I'm going to use a substitution. X is equal to tan theta. So therefore, 1 minus x squared divided by 1 plus x squared is 1 minus tan squared theta divided by 1 plus tan squared theta, which is nothing but equal to cos 2 theta. So let me rewrite y is equal to cos inverse of cos 2 theta. Therefore, y is equal to 2 theta. Y is equal to 2. Based on my substitution, if x is equal to tan theta, theta is equal to tan inverse of x. So 2 times tan inverse of x. That's my y. So dy by dx is equal to 2 is the constant. Differential of tan inverse x is 1 by 1 plus x squared. So final answer can be written in this form: 2 over 1 plus x squared. Let me clear this. Next question. Y is equal to sine inverse of 2x by 1 plus x squared. So again, let me use a substitution. X is equal to tan theta. So 2x over 1 plus x squared is equal to 2 tan theta. over 1 plus tan squared theta. So 2 tan theta over 1 plus tan square theta is secant square theta. Let me simplify this further. 2 times tan theta is sin theta over cos theta divided by secant square theta is 1 over cos square theta. So 1 cos theta gets cancelled. So that results in 2 sin theta cos theta, which in turn we know is simply equal to sin 2 theta. So I'm going to rewrite my y as sin inverse of sin 2 theta. So y is equal to 2 theta, y is equal to 2. Based on this substitution, we know theta is equal to tan inverse x. So 2 tan inverse of x and dy by dx is equal to 2 is a constant. Differential of tan inverse x is 1 by 1 plus x squared. Rewrite my answer. 2 over 1 plus x squared. Next question. Y is equal to secant inverse of 1 by 2x squared minus 1. So here I'm going to use a substitution. X is equal to cos theta. So 2 cos squared theta minus 1 in the denominator is equal to cos 2 theta. So what is 1 over cos 2 theta? Equal to secant 2 theta. So y is equal to secant inverse of secant 2 theta. I get y is equal to 2 theta. So based on my substitution here, theta is equal to cos inverse x. So let me rewrite this. Y is equal to 2 times cos inverse x. So dy by dx is equal to 2. Differential of cos inverse x is minus 1 by square root of 1 minus x squared. So my final answer, minus 2 by square root of 1 minus x squared. Clear this? Next question is say y is equal to cos inverse of 4x cubed minus 3x. So here I am going to use a substitution. X is equal to cos theta. So 4 cos cubed theta minus 3 cos theta is nothing but cos 3 theta. So I'm going to rewrite my y as y is equal to cos inverse of cos 3 theta. So y is equal to 3 theta. Because cos inverse of cos theta is theta. So based on this substitution, theta is equal to cos inverse of x. Let me rewrite my y, 3 times cos inverse of x. So differentiating this now, dy by dx is equal to 3 is a constant. Differential of cos inverse x minus 1 over 1 minus x squared. Final answer, minus 3 by square root of 1 minus x squared. Next question. Y is equal to sine inverse 1 minus x squared divided by 1 plus x squared. So here I'm going to use a substitution. Let x be equal to tan theta. So 1 minus tan squared theta divided by 1 plus tan squared theta is equal to cos 2 theta. So I can rewrite this as y is equal to sine inverse of cos 2 theta. But now to simplify and apply the property from inverse trigonometry, I need to express cos 2 theta in terms of sine. So that gives me sine inverse of sine pi by 2 minus 2 theta. So applying the property now, y is equal to pi by 2 minus 2 theta. So based on my substitution again, theta is equal to tan inverse x. So let me rewrite y minus pi, y is equal to pi by 2 minus 2 times tan inverse of x. So differentiating this, I get dy by dx. Differential of pi by 2 is a constant, which is 0, and minus 2. Differential of tan inverse of x 1 by 1 plus x squared. Final answer, minus 2 by 1 plus x squared. Okay. Next question. Y is equal to secant inverse x squared plus 1 over x squared minus 1. So based on this expression, I'm going to choose a substitution. X is equal to cot theta. So I get cot squared theta plus 1 over cot squared theta minus 1. So this, if I express cot theta as equal to 1 by tan theta, I can rewrite this as 1 plus tan squared theta divided by 1 minus tan squared theta. So we know cos 2 theta is 1 minus tan squared theta divided by 1 plus tan squared theta. So what is 1 plus tan squared theta divided by 1 minus tan squared theta? You take the reciprocal, which is 1 over cos 2 theta. 1 over cos 2 theta is secant 2 theta. So now y is equal to secant inverse of secant 2 theta. Based on my substitution, theta is equal to cot inverse of x. So y is equal to secant inverse of secant 2 theta is simply 2 theta. This y is now reduced to 2 times cot inverse of x. So therefore differentiating dy by dx is equal to 2. Differential of cot inverse x minus 1 by 1 plus x squared, which is minus 2 by 1 plus x squared. Okay, so now let me clear this. Next question is y is equal to cot inverse of 1 minus x by 1 plus x. So here I'm going to use a substitution, x is equal to tan theta. So I can rewrite this 1 minus tan theta by 1 plus tan theta. So I'll introduce a 1 here, and this 1 and 1, we've already seen this in one of the previous questions. This is tan pi by 4 is 1 minus tan theta divided by 1 plus tan pi by 4 into tan theta. This is of the form tan A minus tan B over 1 plus tan A tan B, which is tan of A minus B. So tan of pi by 4 minus theta. So now since it is cot inverse, we have to rewrite this in terms of cot. So this is nothing but cot of pi by 2 minus pi by 4 minus theta, which can be expressed as cot of pi by 4 plus theta. So let me rewrite y, which is y is equal to cot inverse of cot pi by 4 plus theta. So y is now reduced to pi by 4 plus theta, because cot inverse of cot theta is theta. Based on my substitution, theta is equal to tan inverse of x. So y is now pi by 4 plus tan inverse of x. Differentiating this, I get dy by dx. Differential of pi by 4, which is a constant, is 0. Differential of tan inverse of x, a standard derivative, which is 1 by 1 plus x squared. Clear this. Next question is y is equal to tan inverse square root of 1 plus x squared minus 1 divided by x. So let me use the substitution. X is equal to tan theta. Square root of 1 plus tan squared theta minus 1 divided by tan theta. So square root of 1 plus tan square theta is square root of secant square theta, which is equal to secant theta minus 1 divided by tan theta. Now secant theta is 1 over cos theta minus 1 divided by tan theta is sin theta over cos theta. So I'm going to rewrite this, take the LCM as cos theta. Numerator becomes 1 minus cos theta. Denominator remains the same. So to simplify, I can cancel these factors. So 1 minus cos theta over sin theta. Now, what is 1 minus cos theta? 2 sin squared theta by 2. What is sin theta in half angle? 2 sin theta by 2 into cos theta by 2. 2 gets cancelled. 1 sin term gets cancelled. That results in sin theta by 2 divided by cos theta by 2, which is tan theta by 2. So my y can be rewritten as tan inverse of tan theta by 2. So y is simply equal to theta by 2. Now based on my substitution, theta is equal to tan inverse of x. So y is equal to 1/2 into tan inverse of x. So dy by dx is equal to half. Differential of tan inverse of x is 1 by 1 plus x squared. So I can rewrite the answer 1 by 2 times 1 plus x squared. Okay, now let me clear this. Let's do one more question. Y is equal to tan inverse of square root of 1 plus x squared minus square root of 1 minus x squared divided by square root of 1 plus x squared minus square root of 1 minus x squared. I think in the denominator it is plus. Yeah, that's okay. Now I'm going to use the substitution x squared is equal to cos theta. So what is square root of 1 plus x squared? Square root of 1 plus cos theta, which is square root of 2 cos squared theta by 2, which gives me root 2 cos theta by 2. Similarly, square root of 1 minus x squared is square root of 1 minus cos theta, which is root 2 sine squared theta by 2. So I get this as root 2 into sine theta by 2. Now what is inside the bracket? That expression I'm simplifying. Root of 1 plus x squared is root 2 cos theta by 2 minus root of 1 minus x squared is root 2 sine theta by 2. That divided by the same terms but with plus in the denominator. So now I have root 2 common in the numerator as well as the denominator. So that gives me cos theta by 2 minus sine theta by 2 divided by cos theta by 2 plus sine theta by 2. So now you will recognize the form where it is you have to choose to divide both numerator and denominator by cos theta by 2, which gives me 1 minus tan theta by 2 divided by 1 plus tan theta by 2, which you have already seen. This can be expressed as tan of pi by 4 minus theta by 2. So continuing to the next step, I'll rewrite y, which is tan inverse of tan pi by 4 minus theta by 2. So y is equal to pi by 4 minus theta by 2. So what was my substitution? X squared is equal to cos theta. So theta is equal to cos inverse of x squared. So y is equal to pi by 4 minus half and theta is cos inverse of x squared. Now let me differentiate. I get dy by dx, which is equal to differential of pi by 4 0 and minus half. Differential of cos inverse is minus 1 by square root of 1 minus x squared, in this case x squared whole squared, into differential of x squared, which is 2x. So 2 gets cancelled, minus minus plus x by square root of 1 minus x power 4. So that was my answer. I'll clear this. And with this, I will conclude today's session. In the next class, we will continue with differentiation. Again, a few more questions with inverse trigonometric functions. And then we will move on to the next section, which is differentiation of implicit functions, followed by differentiation using logarithms. So thank you, and I hope it was useful, and see you in the next class. Bye.